Hey everybody, Mr. Piercy here, and what we're going to be looking at today specifically the Pythagorean Theorem. Now the Pythagorean Theorem by itself isn't really a new idea. Usually it starts getting introduced in math classes around 7th or 8th grade. We do specifically kind of talk about it in high school geometry, and it is going to be the foundation of things that we'll be doing in this class and that will follow you through future math classes. But one of it's right up there, is probably the most common theorem. It's very easily remembered. A squared plus b squared equals c squared. It's probably the most popular, common theorem in math. It's right up there with E equals mc squared, with its familiarity with just people in general. Now, looking at the vocabulary that we see here, we're looking at something known as a Pythagorean triple. Now, you can have really an infinite number of possible sides for a right triangle that could be used in the Pythagorean theorem. However, there's only a certain set of numbers that generate whole numbers for each side of the right triangle. And those are known as Pythagorean triples, where all three sides of the right triangle are whole values. So what you see on the left side of your screen is the most common Pythagorean triple in all of math. It's called a 3, 4, 5 right triangle. Now the purpose of being able to familiarize yourself with some common Pythagorean triples is really as a time saver. If you were given a right triangle where the two legs were 3 and 4, well, you don't actually have to do the Pythagorean theorem to recognize, well, the hypotenuse would have to be 5 because it's a Pythagorean triple. And so there's a list of Pythagorean triples that you can kind of familiarize yourself with and memorize, so that way when you see them, well, you don't have to actually do the Pythagorean theorem. But of course, that's predicated on the fact that you actually have those Pythagorean triples memorized. And if you do, that's great. If you don't have them memorized, well, that's fine too, because, well, we can always just substitute the numbers in the Pythagorean theorem and find what we need. So here, let's take a look at how we're going to actually be using the Pythagorean theorem. Now, this is something that's not really new to us. We've been doing the Pythagorean theorem on and off throughout the year. In fact, the Pythagorean theorem was the foundation, was the basis of how we developed the distance formula earlier in the year. And we've had to use the Pythagorean theorem to find missing sides of a right triangle and other figures without specifically talking about the Pythagorean theorem already, because it's one of those things that's so common and taught earlier in math other than high school geometry. Now, looking at how things are written here, I have the way it's written, they're kind of saying c squared is going to be equal to a squared plus b squared. So they kind of have it backwards from how we normally write it. A squared plus b squared equals c squared, but that's fine. Now, just so you understand how I look at things, and this is, again, specifically how I look at it, it's not something that's, this is not the way math says it has to be done. I am always going to look at, if I have legs that are different lengths, I am pretty much always going to look at the short leg as being side A and the longer leg as being side B. The hypotenuse is always going to be C. Now, I could say that the long leg is A and that the short leg is B. That's fine. Okay. The main thing that you have to remember here with the Pythagorean theorem is that the hypotenuse is always going to be considered the C variable. Now, taking that into account, we're going to start plugging our values into the Pythagorean theorem. So C, well, that's the hypotenuse that we're looking for, so that's why we substitute x for C in the problem. And I will substitute 7 and 24 in for A and B. Now, we're here at this point, we're really just kind of letting letting our PEMDAS, or order of operations, kind of take over. Do the exponents first, so square the values, and you get 49 and 576. Combine your like terms, and you get 625. Now at this point, what we're looking for is what's the value of x, not x squared. Because what we're looking at, let me just kind of draw this out for you. A basic proof of a Pythagorean theorem kind of looks like this. Let me pick another color here. Where a squared, b squared, and c squared, well, those actually represent the area of a square that's formed by the side of the triangle. So this side here is just A, this side here is D, and this side here is C. So right now I say x squared is equal to 625. That would represent the area of a square made by the hypotenuse as just the side of a square. So to find the value of x, the length of the side of the triangle, we have to take the square root of both sides. And when we do, we get x to equal 25. Now here, that means this particular triangle, because all three sides are whole numbers, we could say that this triangle is a Pythagorean triple. So at this point here, just if you haven't already done so, go ahead and find the length of the hypotenuse of the checkpoint question. Go ahead and pause the video and find the value of that one, and when you're done, hit play and check your work with mine. All right. So hopefully you have your answer here and find the length of the hypotenuse of the right triangle. So looking at the triangle itself, I'm going to look at 9 as side A, the 12 is side B, and of course the hypotenuse is C. So when I go to my Pythagorean theorem, where's my work? There we go. I'm going to start by writing the rule. Now this is something I'm going to become very insistent on. We're starting our unit on right triangles, and there's going to be some very critical information that we're going to be learning in this unit. Anytime that you're going to use a rule, I don't care how often you use it or how simple the rule is, I will expect you to write the rule down, show what you're substituting, and then do whatever arithmetic that you have, whether it's on a homework assignment, a quiz, or a test. Because that is a fundamental math skill in my opinion, and it's going to be something that you really need to remember for future math classes. Not so much the Pythagorean theorem right now, but this is a good place to start doing it. Okay. Now, substituting the values, I'm going to get 9 squared for A, 12 squared for when I substitute for B, and C is what I'm looking for, so I called that x. Squaring both sides, I get 81 and 144. Combining my like terms, I get 225. Take the square root, and I get x equals 15. So again, we have another example of a Pythagorean triple. Now, real quick, just before we move on, let's just suppose that A was, let's say, 2 radical 3. Okay? How I would do that in the Pythagorean theorem? Well, let's just say a squared plus b squared is equal to c squared. Now, the way that I'm going to write this on my paper is I'm going to say 2 radical 3 squared, and I'm going to put the whole side in parentheses. And I'm going to type it on my calculator that exact same way. I'm going to put an open parentheses on my calculator display. Then I will say 2 radical 3, close the parentheses, then square it. Okay? Now, what's happening here, this is essentially in algebra, they teach you about properties of exponents. So what's happening is 2 would be considered a base, and radical 3 would be considered a base. So those bases each have an exponent of 1, and each base is being raised to the second power. So mathematically, algebraically, what's happening is I'm going to take the 2 and square it, and I'm going to take the radical 3 and square it, and when I square the radical 3, that just gives me a 3. So ultimately, what my calculator display should say when I'm done is going to be 12. And we would just continue the problem from there. The main reason why I'm kind of demonstrating this is because on your assignment, sometimes the side lengths are going to have radical values instead of whole numbers. And I want you to know how you should write it down on your paper when you're showing your work and how to type it into the calculator. So if the side length is a radical number as opposed to a whole value, make sure you put the entire thing in parentheses and then square it. So let's look at our next example here. Instead of finding the hypotenuse, now what we're going to use is, can we use a Pythagorean theorem to find the length of a leg? Now, what we would normally see here, the diagram that's been provided for you, sometimes that will be given to you in a problem. Sometimes you'll just be given the word problem itself. And if you're not given a diagram, I really strongly encourage that you draw a picture so you can kind of see what it should look like. And that will give you an idea. Well, I'm looking for this portion of the right triangle. And if you show me what you're doing, what I've seen before is that sometimes people find the wrong values. They draw the diagram wrong. They can do the math correct, but if you have the diagram, a lot of times that's going to help you or make sure that you actually get the side that you're looking for. So if you don't have a diagram drawn for you, I definitely encourage you to draw one. So in this case, we have a board resting underneath a doorknob. Well, if the board is leaning over, that's your diagonal side, so that is going to represent the hypotenuse of the triangle. Then it says that the bottom of the board is 5 feet away from the bottom of the door. So if we didn't have that, I would know that, well, the board itself has to be the hypotenuse, and it's leaning up against a door. So here's the doorknob, and the bottom of it is 5 feet away from the bottom of the door, and we want to know, well, how far up the door does it go? Okay. Now going to the Pythagorean theorem again, they have it written out as c squared is equal to a squared plus b squared. Substituting the values that we have, we know the hypotenuse is 6, and the bottom of the right triangle, one of the legs, is 5. So substitute the values accordingly, and we're going to get 36 is equal to 25 plus x squared. Subtract 25 from both sides, and that will give me 11 to equal x squared. So now, at this point, we have to take the square root of both sides. So the exact answer would be the square root of 11. Okay. Now, the reason that we're not going to stop here is because it does say approximately. Because it's using that word approximately, it's kind of implying that it doesn't want the exact answer. It wants the rounded answer. And it kind of makes sense in certain applications. In a math classroom, we would probably expect you to give the exact answer more often than not, meaning I would stop at the square root of 11. Let's just say you needed to actually find something that long. You were going to Home Depot or Lowe's or something. You wouldn't go to Home Depot or Lowe's and say, I need square root of 11 feet long of something, wood or pipe or whatever. Okay, you would actually take the square root of that value and say, you'd probably go to the store and say, I need something that's about 3.3 feet long. Now, for our purposes, we're always going to round things to 3 decimal places because that's what AP Math expects you to do. So the final answer here is, well, we'd say it's about 3.317 feet. Now, turn the page. All right. So at this point, go ahead and it's essentially the same problem, just with different values. So go ahead and pause the video, answer this question, and when you're done, hit play again and compare your answer with what I have. All right, guys, hopefully we have a good answer here. So again, this is a very typical type of problem where it's just giving you a word problem and expecting you to be able to see where things go. Now again, because they're not providing a diagram, I am going to go ahead and draw a diagram to help me out with it. So again, in this case, the board is underneath the doorknob. So that's the diagonal side. That's the hypotenuse of the right triangle. The bottom of the board is about 3.5 feet away from the bottom of the door. So that is kind of why I'm drawing my triangle the way I am here. Substituting the values in the Pythagorean theorem, working out, and I get x to be about 3.571 feet. Now in this case, it probably wouldn't be appropriate to leave your answer as an exact value because you can recognize, because I have a decimal value for one side of my triangle, I'm going to wind up with a decimal value in my radical. You could stop at the square root of 12.75 feet, but typically a lot of times, because we can't actually simplify that radical, we'll just go ahead and take the square root value of it. So here's a really good example of what I'm talking about. Now I know on your papers when you're seeing this you can kind of see it, but just imagine for the time being that you can't. Here's a very good example of just a word problem that says, hey, this is the type of triangle that we have, and it's actually going to cycle in some prior knowledge for us to be able to figure this out. It's asking us to find the area of an isosceles triangle with side lengths of 16, 17, and 17. Now, again, this is where I'm going to emphasize, if you're not provided with a diagram, you really do need to sketch one out and see what it looks like. So automatically what I would do is because it's telling me I have an isosceles triangle, I'm going to go ahead and just draw a triangle and say it's isosceles. So this is 16. Oops, not 16. That's 17. So 17, 17, and I'll make the base 16. Okay. Now, if I want to know the area of it, thinking my way through the problem, area of a triangle, get my pen back on. The formula for area of a triangle is 1/2 times the base of the triangle times the height of the triangle. Now, one of the things that I do see is a common mistake that students do is students will look at the value of 17 as being the height of the triangle. And unfortunately, it's not. One of the things that we've discussed in prior lessons here, in this case, the altitude, in this case from the vertex of the vertex angle of the isosceles triangle, is going to be drawn in like that. That's the height of the triangle, not the 17. So what we're seeing, because altitude has to form a right angle with the opposite side of the triangle, that's what we determine as the height, because height always has to be the shortest distance from one point to the side across from it, and that's always made from a perpendicular line. So again, we have to kind of remember, well, what are some properties about the altitude of an isosceles triangle? Well, one of the things that the altitude from the vertex angle of an isosceles triangle does is it bisects the base. So essentially what we're doing is we're cutting that isosceles triangle into two congruent right triangles, where the base of the right triangle in this case would be 8. So now I know I have a right triangle where I have a leg of 8, a hypotenuse of 17, and I can use the Pythagorean theorem to find out what the height is. Once I know what the height of the right triangle is, well, that's the same thing as the height of the isosceles triangle, and then I would be able to actually find the area of the isosceles triangle. So again, I wanted to put this screen up here just so that way, I know you can see it on your paper, but just for the time being, pretend that you can't. These are the things this is the thought process that we're going through, that you will have to do on your own when the framework of the problem isn't kind of provided for you. So draw a sketch, just like it says to do. Okay, that's very important in this particular problem. Draw a sketch. And it's giving you the information that I was kind of talking about. By definition, the altitude of the isosceles triangle from the vertex angle bisects the base into two congruent right triangles. Using the Pythagorean theorem, in this case, substituting our values, we're going to get a height of the right triangle, in this case, to be 15 meters. Now, the second most common mistake that I will see students do is and I'm going to go ahead and write down what the mistake is. At this point here, we're ready to find the area. So if I say 1/2 times the base times the height, well, we had to do the Pythagorean theorem to find the height of the triangle. The mistake that I'm going to see students make is this right here. There's the mistake. That is the base of the right triangle. That is not the base of the isosceles triangle that we're trying to find. So please make sure that you use the appropriate base. In this case, the base is 16 meters. That's the base of the isosceles triangle. So when I substitute those values into the into the formula for area of a triangle, that's how I'm going to get 120 square meters for the area. Now, earlier we were talking about Pythagorean triples. The table that you're seeing here is a table of the most common Pythagorean triples and their multiples. So the 3, 4, 5 right triangle, the most common Pythagorean triple that you'll ever see, all of the multiples of 3, 4, and 5 would also work. So if I took the 3, 4, 5 values, multiplied them by 2, I get 6, 8, 10. If I multiplied them by 3, I get 9, 12, 15, etc. So the first ones, 3, 4, 5, 5, 12, 13, 8, 15, 17, 17, or 7, 24, 25, those are the most common types of Pythagorean triples that you'll see, and of course they're multiples. So what I have on the left is not something that we're necessarily going to do. I just thought I'd provide it for the sake of the information that we're talking about. This is a way of generating Pythagorean triples. Feel free to pause the video and copy it down if you choose. One of the things that I'm going to expect you to do is not so much remember the Pythagorean triples themselves. I'm not going to expect you to memorize the table. What I will expect you to do, however, is be able to recognize when you have a Pythagorean triple or not. Okay, so if I say, would these three values produce a right triangle and would they be a Pythagorean triple, you just have to know that the three sides have to be whole numbers for it to be a triple. Now, here, this example is kind of based on the idea of what the Pythagorean triple is in the first place. Okay, it's saying, well, here we have a right triangle where I know the two legs. It's kind of expecting you to be able to just recognize that this is a Pythagorean triple. It says use the Pythagorean triple. So this first method here that we're talking about, honestly, I will never look at it for the values that we have. To me, again, I'm not going to expect, I don't memorize all of the possible Pythagorean triples, and so therefore I don't know simply by looking at this Pythagorean, or looking at this right triangle, that it is a triple. I'm automatically going to jump right to method 2 and use a Pythagorean theorem. And when I do, I'm going to substitute the values and find that the hypotenuse in this case is 51. At this point, I recognize that I have three whole numbers for the sides of a right triangle, so that is what tells me I have a Pythagorean triple. Okay, I'm not going to just recognize that, oh hey, 8 is or 24 is a multiple of 8, 45 is a multiple of 15, and if I multiply both of those numbers by 3, or divide both of those numbers by 3, I can get the 8, 15, 17 Pythagorean triple. I am never even going to think about that because it's just so obscure. Okay, my method is immediately, I'm going to go to method 2, I'm going to just substitute the numbers in the Pythagorean triple, see that the third side itself is also a whole number, and say, oh, now I know I have Pythagorean triple. So go ahead and find the values of these two final problems that we're going to be looking at. And again, this last one here, it says use the Pythagorean triple. I don't care if you use a Pythagorean triple, I just want you to be able to find the unknown side and then be able to tell me whether or not it would be a Pythagorean triple. So go ahead and pause the video, answer these questions, and when you're done, hit play. Check your answers with mine. All right. So looking here, finding the area of the triangle. Now again, they're giving you a diagram to work with. They're not saying, oh, we have an isosceles triangle. Looking at it, you should be able to recognize because two sides are the same, it is isosceles. So I recognize that the altitude that's been drawn in for me is going to bisect the base, so that means each side is 14. So I'm going to first find the altitude, the height of the triangle, by using the Pythagorean theorem, and that came out to be 48. Then I'm going to go to the area of the triangle formula, 1/2 base times height, the base of the triangle itself being 28, not the 14, and I get an area of 672 square feet. Now the next one for the Pythagorean triple, this one I actually could see the Pythagorean triple 3, 4, 5, but if I didn't, I would still go straight to the Pythagorean theorem and work it out. But this one in this case, because it does say 30, 40, well, 3, 4, 5 is the most common Pythagorean triple in the world, so I can recognize that one pretty easily. Otherwise, I would have said 30 squared plus 40 squared equals x squared and done the Pythagorean theorem to find the missing side. And if you did it on your paper that way, that's perfectly fine. All I care about is could you find the missing side and be able to identify if it's a Pythagorean triple or not. So that's pretty much it for this lesson. Can you find the missing sides of a right triangle using Pythagorean theorem? Can you identify if something is a Pythagorean triple or not? And of course, the last thing, again, I'm going to emphasize this again. If you have a side length, that is a radical value on your work. Put the entire side in parentheses and then square it and type it into your calculator the same way. All right, guys, if you have any other questions, or if you have any questions for me, by all means, let me know what they are. And until next time, ladies and gentlemen, thanks for watching, and be good and take care.